Hello everyone, and welcome to the OAI webinar series, Chapter 6, OAI Box, OAI for 5G Research and Education in a Box, presented by OSA Associate Partner Orbismart, and more precisely, Luis Pereira, Software Engineer at Orbismart, and Paulo Marquez, CTO at Orbismart. Orbismart is also an active contributor to OAI, helping OSA with the implementation of new 3GPP specification features and getting OAI more stable and robust to continuously improve results and break new world records. I'm not leaving the floor to Luis and Paolo. Thank you and enjoy the webinar.
Hello, thank you, Camille. Thank you very much. So good afternoon. My name is Luis Pereira from Orbismart. I am here today to present OAI Box. I tried to connect my camera, but unfortunately it is not available. I don't know why. But anyway, I will share my screen later. So maybe as a first step, just to do a simple description of OAI Box. So OAI Box is OpenAirInterface running in a specific hardware or dedicated hardware or customized hardware, and also with a graphical user interface. So this is OAI Box in a simple words. So I will, or Paul Marx is also from our team, is the CTO of the company, and he will introduce OAI Box, and then I will resume after to demonstrate OpenAirInterface and also OAI Box. Paul?
Okay, Luis, thank you very much. I think you can hear me.
Yes, we can.
Yes, I can.
Great. Okay,
can
so
you try to share the screen?
I will share, yes, I will share my screen. I don't know if you can see the slide presentation now.
Yes, I can.
Yes.
Great. Okay, so thank you very much for joining this webinar. As Luis said, so my name is Paulo, I'm the founder of the company, and I'm going to give you some background of our work about OpenAirInterface and the potential of OAI Box. So a quick background about the company. We started in 2015, Orbismart started in 2015. We are based in Portugal. As Camille said, so you are associate members of the OpenAirInterface Software Alliance, and we are key contributors to the OAI code, its development, continuous integration, and continuous delivery. So we do a lot of testing, debugging, and improving in our lab, which allowed us to have always the up-to-date 5G OAI branch in our lab, and breaking the records of OAI speed, because all the hard work that our team does, together, of course, with the OAI community, led by Eurecom in France. So why you are doing the OAI Box? So I have to try here to explain what is behind this. So we are great fans of OAI. We work with OAI for many years in different research projects, and it's a fantastic tool. But we believe that open source doesn't necessarily mean difficult to use. We see from the main lists that there is a lot of people with difficulties to find the right hardware, to extract the key performance indicators from the network, and so on. So we saw here an opportunity to contribute to the community, to building an abstraction layer to facilitate the use of OAI. From the research perspective, I also see that researchers that use OAI should focus on the complexity of their innovation, not all the rest of the 5G stack required for end-to-end experimentation. And in the perspective of graduate students, PhD students, I think they need lab tools to learn 3GPP from PHY to the core network, and goes beyond simulation. And we are also building, thanks to this graphical user interface that Luis mentioned, a tool to understand better the 3GPP, and also a tool for professors and teaching labs to teach students on the protocol stack that is actually used by industry, and not just agnostic modulation schemes or coding schemes as typical is doing at university. So it's a tool also for graduate students that wants to learn 3GPP. So based on this, we start working on this project, OAI Box, an abstraction layer to facilitate the use of OAI for no OAI experts. And this is quite aligned with the OpenAirInterface mission of democratizing wireless innovation. So this is our baseline product that you can find in the OAIBOX.com. So the solution is a box, a computer system that has inside a software-defined radio card from NI, 2 antennas, and then the solution comes with a user equipment, with a SIM card already programmed. We can also provide you iPhones or Google Pixel phones to connect with this 5G test network. If you don't have RF license to transmit over the air, you can use the RF cable kit that you can also provide. The dashboard allows you to configure the network, to extract performance indicators in real time. And you also have a 5G lab manual where we have designed some labs for people that are interested to learn about 3GPP, different aspects of the physical layer, and then you go step by step using the dashboard, configure the network, extract parameters, and understand what actually is going on over the air with a real network. And of course, you have a team of OAI experts that are always happy to help you with any issue that you have in the setup and so on. So this is the baseline model. The OAIBOX 40 is 40 because the software-defined radio from NI, in this case, goes to up to 40 megahertz. So inside the box, what we have? We have the NI software-defined radio, USRP, and the RAN and the core network for OpenAirInterface integrated in the monolithic solution. What is our product, let's say? What is the innovation here? Is that we developed this API network orchestrator that collects KPIs from the core and from the RAN, and then through the internet, a user with a login can have access to this data, can actually use this data for research. You can save this data, play with the data. The system is a cloud-based system, multi-tenant, so each user has his account and can control their test network. It's their test network. In terms of open source, of course, the solution remains open source. The OAI RAN and the OAI core network 5G is open. You can change the max scheduling, you can change the LDPC implementation, the ciphering, everything, and you can see the impact on the real-time plots that the dashboard shows. If you mess it up, which usually happens for researchers and students, you have a button, you just recover the initial configuration of the OAI box with our distribution of OAI ready to use. And although we do a lot of testing, the OAI stack that goes inside the box is tested by us. So we are confident that you can have a good experience using the OAI box. And then we have the Quectel modem that you can connect to the host computer. Luis will show you the details later on. The user can download the collect data in JSON format, okay, for your machine learning algorithms, artificial intelligence, what you want to do. Okay, I'm going to give you a video. The video is in the website, but just to give you an example how to use the OAI box in an industrial environment. So we are challenging ourselves in terms of radiation scenarios. We are using here the OpenAirInterface connection. You saw the OAI box over there. You are here using iPhone 14 Pro to do speed test. You are reaching more than 100 megabits per second over 40 megahertz bandwidth. You also can configure the TDD configuration, and this is a scenario from our partner that allowed us to do this testing. And the idea is also to understand what are the risks Here we are using the antennas that comes with a OAI box. We are transmitting 10 dBm power. We will go 100 meters with no problem. And here the test is an augmented reality application that is used by training step by step an industry 4.0 scenario where the technician is using augmented reality application to do a specific job. In this case is a calibration of a mechanical machine. Here the issue is not the throughput, it's more related to the latency of the holograms that are projected. Is I think a nice use case of 5G using in this Industry 4.0 application. Although, you know, the OAI box is not for commercial deployments, is not for implementation of private 5G networks. We sell the OAI box for research labs, universities, for testing your research ideas, your innovations. Although you can use and test it in your university campus as a test network, not as a network has a service level agreement, for instance, okay? So the network is not prepared for this. It's a tool for research and experimentation. You can see here this application, and then in the back office, you have the OAIBOX dashboard to monitor, to control, to extract the key performance indicators in real time. And these metrics will be available for post-processing in case you want to use them. So these are OAIBOX 40, where the card, the software-defined radio card, comes inside the box. But you have other models like the OAIBOX 200, and we have already some customers asking for this, because imagine you have already a USRP in your lab. So the solution, in this case, the USRP from NI comes outside. You just have to connect to OAIBOX 200 to have a MIMO times 2 times 2, sorry, and that goes up to 800 megabits per second. You can connect an amplifier or an external antenna in case you have a license to transmit over the air, and then you have an end-to-end 5G network with MIMO that allows to do a lot of experimentation and testing. So this is the concept of bring your device. Okay, you can use your own USRP N300 to connect to the box. Okay, so what else? We are working in parallel on the manual, mainly for teaching labs. If you are professors at universities who want to teach students about 5G, look to this. We are creating exercise based on the graphical user interface. The student just has to change the bandwidth from 40 megahertz to 20 megahertz, and they see the impact on the throughput. They change the TDD configuration, they change the transmit power, and then we invite the students to understand, to report the measurements. So it's a kind of test network in the lab for teaching 3GPP. The download is possible to download the sample of the manual. We have almost 200 downloads now, so it seems it's quite getting quite large attention of this. Of course, with your support and your feedback, we'd like to go further. Now we are mainly on the physical layer, but you see here opportunities to have labs for the MAC, LC, PDCP, even the core. Okay, so is it possible to customize the OAI box? Yes, it's possible. So we sell the OAI box 40, but for instance, in this case, our client, Acelerecom, that is a company with expertise on implementations of the physical layer algorithms, they ask us to customize a OAI box 40 to include a T2 telco card from AMD Z-Link, where the LDPC is offloaded, the LDPC implementation of Acelerecom. And we were able to demonstrate through the dashboard that it's possible to save the CPU load more than 30% thanks to the design and the expertise of Acelerecom in the way they implement the LDPC offload. So an example how we can customize for a specific research project that you have. Or if you are, and this was demonstrated at the Mobile World Congress in Barcelona at Acelerecom, Both I'm here together with Luis and Irfan, the head of operations of OAI. Great. So ORAN is also a topic of our interest. You know, OAI already supports split 7.2 with VVD and radio units. So this is also available. We can split the box into box, have the DU, have the CU, have the radio. So it's just a matter to challenge us to design a specific setup for your requirements. We have a growing number of customers, although we start quite, let's say, 2 months ago, promoting the product. Customers like European Space Agency, University of Paris, OLU, or research centers in South Korea, or in more remote places. For instance, BATS is a wireless expert company in the US. They are building a 5G test lab, and they are using the OAI box. But more than the customers, we are also proud of our free version. We have a free version for the good of the OAI community. We are working on a free version that allows you to have a limited number of features that you can use to monitor your existing OAI setup. So we also invite you to test it. And I'd like to share some feedback that we got, for instance, testimonials from Ali Reza, students from the Iran University of Science and Technology, saying, congratulations, you are doing a very valuable and practical project. Or an engineer, software engineer from Vietnam, saying, to be honest, I cannot wait to try it out. I'm installing it now. Thank you so much for your help. Or an email, I always smart team, congratulations of your hard work. You are actually doing the features that is missing in almost all open source solutions. So apart from the business, of course, you are a company, you need to make business, but you also contribute to the OAI community with this kind of free solutions to facilitate the use of OAI in distant places like Vietnam. Okay, how to contact us? Easy, just to go to the form, oaibox.com. We are looking forward to have your feedback. This is essential to improve our offer. And in our 2 days demo, that now I'm going to give the floor to Luis, is I think the more important part of the webinar. Just to give you what Luis is showing is a tool on our OAI Box 200. So it means you can have 2 times 2 100 megahertz bandwidth with a USRP N310. We can connect a Quectel modem with a SIM card that goes with a solution, or you can have an iPhone or a Pixel 6. And now I'm going to give the floor to Luis. Thank you for your time, for your support, for our customers. We'll continue to work hard to make the solution even better. And please give us your feedback. So I'm going to stop sharing, and now, Luis, the floor is yours. Thank you.
Okay, thank you very much, Paul. I will try to share my screen. Okay, hope you can see it. So,
yes,
since we
yes,
are actively working and contributing to OpenAirInterface codebase, I will try also to give you an update about the latest features on OpenAirInterface, not only related with OAI Box. I'm trying to hide this, but I don't know how to hide. Okay. So, yeah. So to start, so all the people need to sign in with the login email and password. And then you will have this dashboard where you can select here on the top left the OAI box if you have multiples. In this case, we have, I have these two. OAI Box AM5 is the one that we will use. AM5 is just because we are using AMD Ryzen 9 CPUs. So with the new AM5 socket, That's it. So here on the left, we can also see, in this case, the USRP N310. So it supports at least 2x2 and 4x4, but for this demo, we will use only 2x2 because, as you probably know, OpenAirInterface is not stable enough with 4x4, 4 layers downlink. Core network, we can upgrade or start the core network. So, for example, we can see the current status of each module: AUSF, NRF, UDM, UDR, AMF. So we need to wait 23 seconds to get all the core network modules up. This is OpenAirInterface core network. So you can go to the OpenAirInterface website to check the models. So we are using these ones in this website. Okay, so the core is all up. We also can see here the internet connection of the OAI box. This is very important because if you have a very poor internet connection, for example, with 30 megabits per second, you cannot expect 200 megabits per second if your internet connection does not allow it. And for example, here on the GNodeB, we can do some configurations. This is a default and pre-configured configurations, but the users, I will show it later, can go to the OAI source code and change whatever configurations the users want, and they will reflect here. So this is just some default values that we can choose. So we can choose, for example, band 41 with 40 megahertz bandwidth, for example, with this TDD configuration, 7 slots downlink, 1 flexible and 2 uplink. We can choose the number of antennas. So as I said before, currently we will use only 2x2 maximum, not 4x4. And we can also enable some PCAP captures, both on the NGAP interface and also on the RRC, MAC, RLC, PDCP. But okay, for now we will use only this. We can reset the configurations. We can upgrade the GNodeB source code. For example, today we will run with the latest develop from OpenAirInterface. So if you go to the OpenAirInterface website, I am running with develop, the latest one from 2 days ago. And we can compile also from here, and we can also start the GNodeB. While starting, we can check, for example, the well-known OpenAirInterface logs, as you can see here. Okay, so I have this computer connected with a Quectel. It is connected, but it should not be connected. But anyway, I will disconnect. So my mistake. So it is disconnected. I will connect the UV again. For example, very easy with a Windows computer. Just need to click here, and we can see the IP address here. For example, we can do some speed tests. Okay, go. So in the meantime, I will move to the dashboard where we can see here on the middle, on the right, the downlink throughput in real time, 134 megabits per second. And now the speed test is doing the uplink speed with 24, 25, 20 megabits per second. So we can see it in real time. We can also check the UE's other metrics, for example, RSSI, RSRP, RSRQ, power headroom, and so on. For example, CQI, MCS, Blare, bitrate. Again, for this specific UE, in the other page is the aggregated throughput. Here we can also do some comparisons between, for example, we can enable only CQI or no MCS and bitrate or whatever. Okay. So we have these metrics, 128 and 19 megabits per second. Now, for example, I want to enable two layers, MIMO 2x2. So what I need to do is to disconnect the UE. By the way, if I try to, okay, we will keep 40 megahertz. We need to stop the Gino bit. Okay, TX 2 antennas and RX 2 antennas. So we just need to start again. We can check again the logs. Okay, it is running. We can connect again the UE. Okay, so we have again the same IP address. I will open in a new tab to compare later. So now the only difference is MIMO 2x2 and before with a single layer. So we can go. Okay, so 200 megabits per second downlink, for example. And close to 40. Let's wait. Okay, 41 megabits upload. If we come again to the dashboard, we can compare here 134 and now 227. By the way, since we enable two layers, we could expect twice the downlink throughput. Okay, but the problem is our internet connection is limited to 210, 220 megabits per second. That's why the maximum we got is 220 on the physical layer, plus headers and so on. So this is because of our internet connection. Okay, so now what we can do to compare again, we will disable. And now we can change also the TDD configuration. We stop the Gino bit. For example, this throughput is not enough for me, for my specific tests. So I want more uplink. The one way to have more uplink is to change the TDD configuration. For example, we can move to a 2.5 milliseconds TDD configuration and keeping the same two antennas, TX and RX. So just by changing the TDD configuration. So we will have less downlink slots, but twice uplink. Okay, so we start the Gino bit. Okay, still running, already running, okay. We connect the UE again. Okay, we have again the same IP address. I will open a new tab. And now go again. So because now we have less downlink slots, the downlink will be less than the previous test, but we expect a few more uplink. Let's wait. Okay, so just by changing the TDD configuration, we move from 41 maximum uplink megabits per second to 67 megabits per second, just by changing the TDD configuration, okay? Okay, we can compare all the values again. So single layer, 40 megahertz, 128 megabits per second, 20 megabits upload. By enabling MIMO 2x2, we got more than 200 megabits per second downlink with 40 megahertz and 41 uplink. By changing the TDD configuration, we got a few less megabits per second downlink, but still very, very high. But the uplink increased to close to 70 megabits per second. So we can do this very easy, very simple with OpenAirInterface. As you can see, OpenAirInterface allows for a wide variety of configurations already. So for example, now I want to show one last thing. I will disable again the Quectel. This could be done with a mobile phone, but okay, to show the speed test in a browser, we decided to use a Quectel modem. We stop the Gnode. Okay, now we want to use, for example, 100 megahertz. Since we are here, with the TDD configuration 712 to have maximum downlink throughput. So we start this will be, we can check the logs. Okay, it is running. So because of our internet speed is only 200 megabits per second, I cannot do a speed test anymore because the speed test will be the maximum of the internet connection. So for this specific test, I will use iPerf between the UE and the core network. You can ask in the chat if you have questions, but it's the only way that we have to test maximum throughput. Okay, just checking the IP address, .2. Okay, so now I will start iPerf on the core network. I have here a session. Okay, this one. Okay, I will request 650 on the application layer. Okay, so let's see what happens. I can go here to the UE where we have 680 on the application layer. Okay, so if we go to the dashboard, again here, we can see on the dashboard, so on the Mac layer, 700 megabits per second with a single UE. Okay, so now what we can do is, because the code is open source and we are running the develop OpenAirInterface as it is, the user can also go to the source code and change configurations. For example, now I will implement a banded part switching algorithm. This is also important for other research projects. So we use CLion, and I will edit the source code directly of OpenAirInterface. And for this, we also can check the lab manual here on the dashboard, where we really teach how to do a banded part switching algorithm. Okay, we explain what is banded parts and so on. And we explain here how the user can implement a banded, just for demonstration purposes. This is not good, but okay. I have here in a text file to be easy. So we need to edit this file, the configuration file, and to add the banded parts. I will use this. not here. Okay, so we just need to go to the OAI box configuration file that is here. We change the values as explained in the lab manual. But wait, I need to do one thing first. I will change to 40 megahertz back. And I need to stop the GNOB. Okay. 40 megahertz, single layer, no need to have multiple layers. Oh, sorry, I stopped on this. So we open the source code as it is, plus this configuration file, but you can use other configuration files. I will change some parameters here to be as explained in the lab manual. And I will add here the dedicated serving cell configuration that contains the specifications of the bandwidth parts. So we can add it here, for example. I will try to explain what we are doing. So we add a bandwidth part 1 with this location and bandwidth. So if you know the standard, it means RB start from 0 with a length of 106, which means it corresponds to 40 megahertz bandwidth. To carrier spacing 1. We have a second bandwidth part with 20 megahertz, so half of the first. And we have a third downlink bandwidth part with only 10 megahertz. So 10, 20, and 40. And the same for uplink configuration. So one uplink bandwidth part with 40 megahertz, one uplink bandwidth part with 20, and another with 10. And this finalizes the configuration. So now we need to go to the C code, C files. So here it points to the GNOD scheduler primitives.c, where we need to copy paste this function. This is just for demo purposes, but okay. And we copy this. I will copy from this text file to avoid issues. Is the same code. So GNOD scheduler primitives. This one. So it says that we need to add this before one function that is there called scheduler and our BWP switch. So let's find the function. Okay, this is the function, so we just need to add the other function here that performs the scheduler. Okay, this function does the scheduler between the different bandwidth parts. And also, we need to add one more thing in this function, that is these two lines. Okay, copy, not here, sorry. And here inside this function that is already there, we just need to call the previous function with a periodicity of 30,000 slots. So it means 50 seconds. So what this algorithm does is it will change bandwidth parts from bandwidth part 1 to 2 to 3, and then come back to 1, 2, 3 every 15 seconds. Okay, we can save. And that's it. So we have two options. We also teach how to build as a OpenAirInterface usual tutorials that you can see there. You can build like this, or I will do save, close. Or we can build here on the dashboard on this compile. So we can do both ways, to compile in the dashboard or to compile in the in the terminal through SSH or using TeamViewer or using other remote desktop. So we need to wait about 2 minutes to compile everything. So this is the UE, it is disconnected. Okay, we can also see the logs while it is building.
So while it builds, hi Luis, this is Francesco.
Hi, Francesco. Yes.
Yes, just maybe a reminder about this bandit part.
Yes, sure. You can.
For yeah, I mean for people that might be not aware. So it's good that you are showing this functionality, but there should be a reminder that this is not a, let's say, standard implementation, or I mean that's why it's not in the code base yet. I mean, what is missing is, I mean, this is good for showcase, but what is missing currently in OpenAir is the a proper intelligence to do bandwidth parse switching. I mean, the algorithm, a true algorithm that decide when the GNB should switch bandwidth part. Currently,
Yes.
we didn't develop this yet because well, this might be useful, for example, in quality of service. I mean, for providing different bandwidth part to different quality of service, or to have a small initial bandwidth part for random access, etc. That for now we don't use. So yeah, people should be aware that this is not a proper implementation of the switching. But it's
Yes.
good that you show that in principle it's supported by OpenAir.
Yes, thank you very much, Francesco, for this feedback. So yes, this is just for demo purposes, as I said, and the bandit parts. Maybe this is not the proper goal of bandit parts, but well, we are just showing how to, for example, to do it on the code, and how the UE answers to that. So the Quectel, that the modem that we are using, it supports, it will change between bandit parts, as we can see later. So this functionality is already somehow implemented on the OpenAirInterface, and it is supported on OpenAirInterface. But of course, the algorithm is up to the user and to the implementation. So I will start the GNodeB again. Okay, it is running. I will connect the UE once again. Okay, it is connected. So for this, I will run again iPerf because I want a continuous downlink flow. Let's do this again. .3, I will request 125 for example. And here on the UE, we are receiving at 28 megabits per second because it is on bandwidth part 3. Now the UE and the GNodeB move it to bandwidth part 1, so 40 megahertz. So we get 124 megabits per second during 15 seconds. After 15 seconds, the GNodeB changes bandwidth part from bandwidth part 1 to bandwidth part 2. So it is half of the bandwidth. So we expect half of 134. So we get 63 megabits per second. After 15 seconds, we get half of the previous one because the bandwidth part is only half of the size. So we get close to 30 megabits per second. Now this changed. 15 seconds later, the UE moves back to bandwidth part 1. We get again 134 megabits per second. And then it will move to bandwidth part 2 again. And so on. Okay, so here on the lab manual, for example, we teach exactly how to do that on the source code. So the user is not limited to the options available on the dashboard, but the user can really change the source code to do its own configurations, and the output will appear and will reflect here on the dashboard. Okay, and we can also see here again the metrics. Okay. We also have this on the right side, we can see some NGAP messages. Okay. For example, this one with the PDU session restore setup request, but as I said before, we can also see other messages that I will enable now. I will stop everything. Stop the UE. Because the other messages, the number of messages is very high, so I cannot run download traffic with the messages enabled, otherwise they are too much. Okay, so what we need to do is, okay, we can reset the configuration. Band 41 again, for example, 100 megahertz, and I will enable the PCAP. Start. Starting. So this is mainly for debug. Okay, stop it. Okay, this happens sometimes. Start. Okay, I guess I still have the hardware running, sorry. Okay. So connecting the UE again. We can see now, for example, this NR RRC with RRC setup, RRC setup complete, identity request, identity response. So we can have, or we can see also these kind of messages for debug to understand where the UE stopped. Or we can go here also for those who understand and try to debug with these messages. Okay, and this is what we have for today to show you. So as I said, in the beginning, we are working on MIMO 4x4. When I say we, I mean OpenAirInterface, because we are actively contributing to OpenAirInterface. But it works somehow for some configurations, but not for the full 100 megahertz and full MCS range. So we are still working on that, but contributions are welcome. Not sure if there are questions or other scenarios that you want me to show. You can ask.
Luis, just to emphasize, if you have multiple UIs, what happens?
Okay, so in case of multiple UIs for this setup, we have a single one. So we have here only one UI, but we can connect multiple UIs. We will have other UIs here. And for example, with more than one UI, we can get more downlink throughput in case of this specific configuration. That's why we can get more than 800 megabits per second. We need the two UIs for that specific record. But yes, we can use multiple UEs, 4, 10, I guess. Not sure if someone wants to add more details about multiple UEs. And that's it.
And Luis, in case I'm working with the code and then I mess it up, how can recover the initial configuration?
Okay, so for example, here in the Shinobi scheduler primitives, I added this code, bandwidth part switch algorithm, and this function, but now the UE cannot connect anymore, for example, or the build fails. Then we can just close. And for example, we can go here to the upgrade and we can choose a version to upgrade. For example, this one, the same, and proceed. And this will reset here upgrading. This will get the code again and reset all the source code. So the setup will work again without any issues from the beginning. Okay, so we also have this functionality. We can also upgrade the core to get the latest OpenAirInterface core network images. And we are providing upgrades almost every week because OpenAirInterface evolves quite fast and we have fixes every week. So the same here because we are running OpenAirInterface almost as it is. So we have just small features, for example, to export the metrics that are not presented in OAI base code, but the code remains the same.
Okay, for instance, Luis, we have also customers asking for handovers between OAI Box. How do you see this? Something that will happen soon?
So as I said before, we are using OpenAirInterface as it is. So for that specific use cases, even if we develop that feature, for example, for our own purposes, it will be available on the OpenAirInterface repository. So you need to go to the OpenAirInterface website and check the roadmap, what will be the next features, and you can also attend the meetings to be updated of the fixes and new features every week. And yes, that's it. So we are aligned with OpenAirInterface roadmap. So for now, the handovers procedures are not implemented because we at OpenAirInterface, we are mainly focused on the splits, for example, 7.2, FAP interface, and F1 split, E1 and E2 interfaces, for example, to implement RIC. But yes, OAI Box for now is a monolithic solution, but we also plan to make available another solution that supports splits in the future.
Okay, thank you.
Hope this answers the questions, but if someone on the meeting wants to do some questions or even about OpenAirInterface, they are welcome.
I have a question. You are showing a dashboard with the UE stats, RSRP, RSRQ, MCS.
Yes.
How is it integrated from Quectel into this thing or something else going on?
Well, it depends on the metrics. So there are metrics here that are, now it is stopped, but okay. Metrics that are computed at the Gnode beside, okay? And there are other metrics that are reported by the UE using the UE measurement reports.
Correct.
that you need to configure, because if you use the latest develop, there is a function that configures the measurement report on the UE. And then after that message being accepted by the UE, because there may be some UEs that does not support it, but okay, UE starts reporting accordingly with the configuration of the measurement report configuration.
Very good. Thank you. And last question, on the logs you were showing the messages, can you decode those messages, NGAP and NAS messages?
Okay, on the dashboard, for now, not yet. Okay.
Okay.
You can just see the sequence of the messages for now.
Okay, thank you.
But since there
But
are
Luis, you can,
not-
the users can use Wireshark anyway.
yes, exactly. So in the manual, we also teach how to configure. Well, not sure if it is on the public version, but anyway,
Okay.
we also teach how to configure Wireshark to collect directly all of these messages. So on the host computer, because for now we are sending the messages to this dashboard that is not local, it is on the cloud. So you can access using a mobile phone, for example, this dashboard, and you can monitor in real time. And also multiple users can access. So we cannot forward all the MAC messages or RLC messages to a cloud using internet connection. Otherwise, the internet connection will be flooded with too many messages. But yes, you can do it locally on the OAI box. If you connect the screen and the keyboard, you can do it locally, yes. We also teach how to do that
With a Wireshark.
with Wireshark, yes, for example. Because OpenAirInterface, for those who don't know, but we have at least two different mechanisms to collect messages. For example, the MAC PDUs, the RLC segments, and PDCP messages and RRC messages directly from the ZNodeB stack. So we have two different mechanisms. One is the T-tracer. You can search on the OpenAirInterface website for that. And the second is just doing a Wireshark forward with OPT. That one I can show it to you. So you just need to add two parameters on the command line, and ZNodeB will send MAC and RLC messages to the Wireshark, to the localhost interface. For example, where it is. Yeah, so here, this one. So you just need to add these two parameters, opt.type Wireshark and opt.ip, the IP address where is running the Wireshark, and Wireshark starts receiving MAC, RLC, PDCP, RRC. But you can also use T-tracer that has other features available for debug and troubleshoot OpenAirInterface code and message flows. Any other questions, even related with OpenAirInterface?
Luis, there are questions in the chat regarding the implementation of E2 and how we extract the key performance indicators. Can you elaborate on this roadmap for the E2?
Okay, I know that there is a merge request to integrate the E2 agent on the ZNodeB. So people can use it now, but it is not integrated into develop branch. Okay, so it will take a few more weeks or months. I don't know exactly when it will be available on the develop branch. But for those who really want to test the E2 and the RIC interface and RIC features, well, there are some work needed to integrate everything and to start, but it is also possible to get some metrics using the E2 agent and the Flex rig. There is also a separate project where people can access, but we had a webinar, I don't know, but a few weeks ago related with Flex rig, so no need to repeat it again. Okay. Not
Luis,
sure
in,
if there are
in
other
terms of,
questions.
yeah, there is question in terms of coverage. What your practical experience says in terms of we having line of sight with a mobile phone?
Okay, so with the mobile phone, we are limited to the USRP max transmit power and max receive sensibility. But okay, with the B210, we can get in a line of sight at least 100 meters with good coverage, yes. But the users can also add, if they have the license to transmit over the air, they can add a power amplifier and external and outdoor antennas. So it will improve a lot the coverage, yes. The same for the N300 and 310. So it transmits with less power, but the users can add a power amplifier to improve the coverage. And also we can also add to integrate it and to test it.
Okay, there are key questions about the virtualization. If you can have a virtualized version of the solution. I don't know what are the means.
So if the question is to yes.
Maybe to say, maybe for instance, the core network, we are using the OAI core network, okay? But you can connect to other cores from other vendors and other players.
Yes, exactly. So in our solution, we have the OpenAirInterface core network that we also help to improve. But other core networks are supported by the GNOD. So you just need to play with the configurations and to add configuration, to change the GNOD configuration to use another core network solution. So it is not very easy, but it is not related with the OpenAirInterface. It is related with the networking stuff. You need to add static routes. You must have the proper MTUs configured on both endpoints. Well, so in this point, because sometimes people think OpenAirInterface is complex, but in fact, it is the network configuration that is not easy. Okay, so you need to really understand network configurations to connect a GNOD-B or multiple GNOD-Bs to a remote core network. And then, of course, you need to configure other core network solutions because here we provide the core network already pre-configured with end-to-end communication. But if you want to deploy a different solution, you need to understand how to program a SIM card. What is SST, slice service type? What is slice differentiator? What is MCC, MMC? So what is the EMSI on the SIM cards? So it is not easy to configure from the scratch a 5G network. Okay. So the complexity is not related with OpenAirInterface because sometimes on the mailing lists there are these kind of questions, but the complexity is on the 5G itself.
Okay. Also,
Okay,
there is a key some.
Yeah.
Okay, just
Okay,
going to the
I
chat.
can also add one more thing that is also it appears a lot on the mailing lists. So the SSB ARFCN, so the user cannot just choose a frequency and try to get a commercial mobile phone to work, okay, because the SSB must be in very specific frequencies, okay. So even this parameter must be very well computed to get a mobile phone working with a 5G connection. So sometimes the issue is not on the mobile phone itself, it's because of this parameter that it is not well or properly configured. Yes, Paul, do you have other questions?
No, it's just also there is a question in the chat regarding the FAPI. How is the FAPI implementation now? And
well, I'm not sure if I could or if I can answer that here, but there is meetings, OpenAirInterface meetings, where the users, for that specific user, that should attend and do the questions there, because this is out of, that topic is out of the scope of this meeting. Okay, so if there is no other questions, Camille, I pass to you. Not sure if you want to add something. I will stop the share.
No, that's fine. So I just want to thank everyone for joining the webinar, and thank you, Luis and Paulo, for this great presentation. And I hope to see you in the next OAI webinar. Thank you very much.
thank you very much.